Hello and welcome to this week's What Were They Thinking? Among the news items we have for you this week, there's the shortcomings of the ABO blood typing system, the current lawsuits against Walmart amongst other large retailers for mixing ineffective medication with effective medication. Data further supports the contention that vaccines not just provide protection, but other benefits to children. The benefits of caffeine for adults, biology inspires circuitry that could be used for computing, and 3D implantable computer chips. The timestamps for these and other news items can be found in the description box below. Let's begin with something that's generally taken for granted. There are 4 blood types in the world: A, B, AB, and O. You can be rhesus positive or rhesus negative, but generally speaking, you are going to know you are one of those 4 types of blood, if you know your blood type at all. The problem with this is that blood is a lot more complex than just the 8 possible derivatives of that particular system. In fact, there are many hundreds of possible antigens on a red blood cell that could be used to define it. The ABO and rhesus systems are simply some of the most convenient and long-standing. This is where new research into a new specific analysis to identify a particular blood type could help with newborns. This new blood type system is called the system, and it is, at the moment, largely based on the loss of a pair of newborns that provided the insight into the particular antigens needed to recognize it. There are 2 kinds of protein, A and B. These were first identified in 1982, and have been conclusively demonstrated to be clearly established. This means that they are another possible antigen site that can be tested for, and technically make up the 44th blood group. As mentioned, there are many kinds of antigens that can be used to establish what your blood is actually made from, and this is especially important for things like childbirth, pregnancy, and for blood transfusions of those who are pregnant. In other cases, it can be for things like leukemias, where you need regular blood transfusions since your own red blood cell production becomes compromised. With regards to the antigens, it's particularly important as the antibodies can pass through the placenta, which should normally be well protected from this, and flag the developing fetus as being foreign, leading to the body trying to remove it as a foreign thing, particularly pathogenic thing. This then leads to hemolytic disease of the unborn, and you have either preeclampsia or an undesired and unwanted abortion. This is where the loss of the recent infants comes into play. It was established that the blood being transfused for the mothers in question was unable to match with the recipient, and so the body began making that reaction, and that reaction led to the loss of the infants. Having had that initial study, they then expanded it to look at other possible lost pregnancies, and they found in 13 patients that there were more variants of the antigens, A, B, 3, and 4 and 5, which are very new and come about from this study. The gene that gives rise to this is the psuedo, and that's associated with mechanoreceptors on the red blood cell to know when force is being applied to it. Mice without this gene die before birth, and those that lose it end up with red blood cells that are liable to become overhydrated and liable to explode. This is not a good sign. This means that we already know about the gene and some of its roles, but now we found a new application and a new reason why you need to look out for it. And more importantly, look out for it especially with things like pregnancy, but it could have relevance in many other different diseases. For example, malaria, which tends to target red blood cells particularly because that's where the parasites hide. This is particularly important as hematology has not simply come to an end of its research branch. In fact, that branch continues to grow. The more we know about how red blood cells behave, what's on them, and how they interact with other parts of the human body, the more we can try and use that knowledge to better people. The same thing can't be said of Walmart and CVS, amongst others, who are currently facing a lawsuit, and it's being chaired by 3 judges. The original lawsuit was dismissed because people were claiming that by putting homeopathic products next to real medication, people weren't able to differentiate. and unfortunately this is true, or at least in our opinion. The lower court did not believe that, and so the lawsuit was dismissed. The 3-judge panel that's currently hearing the case has reversed that decision, stating that no, people really are that dumb. And it's good to see that the judges at least recognize that humans can be stupid. The gist of the lawsuit, as said, is that by placing ineffective homeopathic products next to legitimate, well-proven medications, although over-the-counter, leads people into thinking that nonsense does actually work. This is something that's not restricted to just the named parties though. Many supermarkets and other stores will do exactly the same thing. It's just that they happen to be named in this particular instance. The party that began this back in 2018 is the Center for Inquiry. Their lawsuit at this stage, although supported by the 3-judge panel, has very clearly been stated to, at this point in time, require more evidence to substantiate the rest of what they're claiming, but that the judges state, it is not implausible that a reasonable consumer might understand that placement of homeopathic products alongside science-based medicines as a representation that the homeopathic products are efficacious or are equivalent alternatives to the FDA-approved over-the-counter drugs alongside which they are displayed. We've demonstrated already that homeopathy does not work. The reality is that by the time you get through 10 or so dilutions, you have so little of the original product inside the bottle that you would be lucky to find one molecule in the equivalent of the ocean, let alone what you've been sold as a productive, effective treatment. Not all treatments are universally effective, and you need to be able to demonstrate this, and that is where homeopathy and real medicine differ. Real medicine demonstrates that it can work through repeated clinical trials, unfortunately animal research, and often even before that in cell and culture-based research. Not all researchers, though, are ethical in what they do, and Dr. Oz is an example of this. Unfortunately, his team has most likely violated one of several different research principles and possibly welfare acts for animals. Their research involved over 300 animals, specifically dogs, and unfortunately killed them. However, this is not a single study, so at least there's a small saving grace in that respect. Rather, it is 75 different studies spread out between 1989 and 2010, which may not actually be an improvement. It means that somewhere, somehow, Dr. Oz received ethics approval to kill over 300 dogs over 21 years for research that didn't go anywhere. This would not be such an issue for Dr. Oz if he were just one of the researchers. Rather, he is the principal investigator. This means he actually has responsibility for everything that was done under his watch. He has full administrative and fiscal responsibility for what he did. And this includes all the dead animals that did not need to die and did not need to suffer. We recognize that, yes, animal research is necessary at this stage. There are currently no viable alternatives in some respects. Unfortunately, that's a reality of the situation. That doesn't mean that you need to jump straight to animals or that you should not follow the 3 R's, and better yet, try and find any alternative that you can possibly do before subjecting an animal to unnecessary treatments. Dr. Oz's team does not seem to follow this. More than 1,000 live animal subjects were included, with dogs, pigs, calves, rabbits, and rodents. 34 of the experiments had 329 dogs die, 2 experiments killed 31 pigs, and 38 experiments killed 661 rabbits and rodents. That is a lot of animal deaths at his feet. The problem Dr. Oz faces with this is twofold. The first is that he may well have violated the Animal Welfare Act. This sets minimum standards for the care of various animals involved in research, and as a result, since he's the principal investigator, he is liable for failures, especially when it comes to violations of this act. Failing to meet the minimum standards is something he had to make sure they did. And so, when looking at what they've done, and we'll provide a link to the article, as chances are good YouTube will balk if we try and describe it too much, you'll find what their failures were and which laws they particularly failed to follow through on. It's true that we would not exactly expect that Dr. Oz, given that he so freely preys upon people who are not exactly well informed, would care much for the welfare of animals, but we would have at least hoped somebody who graduated from medical school would have some kind of moral, ethical, minimal standard. Humans, sure, they're dumb. Take advantage of them. Animals, who I have a responsibility to care for and look after, I'll make sure not to cause them unnecessary suffering. But no. Dr. Oz doesn't care for anything or anyone but the bottom line. Going from badly designed research resulting in unnecessary suffering to the results of good research, and specifically vaccines. Vaccines are one of the longest types of medication we've had available, specifically going all the way back to the Jenner experiments where cowpox was used to protect from smallpox. This is where research into the impact of childhood immunizations, that's vaccinations, leads to benefits of preventable diseases in the United States of America. It comes from science-based medicine, and the study found that vaccinating for things like diphtheria led to fewer than 1 case a year when you had full coverage. Approximately 7,000 cases of hepatitis A with just 87% coverage, hepatitis B with 22,000 cases with 86% coverage. That influenza type B had fewer than 100 cases with 100% coverage. Influenza, the other kind, had approximately 5.9 million cases with 17% coverage. Measles with 100% coverage, fewer than 1,000 cases. Mumps with 100% coverage, 3,000 cases. Rubella, less than 10 with 100% coverage. And it goes on to cover things like pertussis, streptococcus pneumoniae, polio, rotavirus, tetanus, varicella, and more. It then points out how many cases were prevented when looking at it this way. If you had no coverage, and we know this from earlier data, versus what happens after you get to a certain level of vaccination, they can tell us how many cases were prevented. And to be blunt about it, it's very clear there are a lot of cases that were avoided. The next is a study that looks at data as well, but this time you need to take it with considerably more salt, primarily because this is entirely a retrospective analysis and it is observational. This means the data did not have an experimental design to it, rather they got data from the UK Biobank. The researchers then looked at those who consumed 2 to 3 cups of coffee each day. They found they had longer lives and lower cardiovascular disease risk compared to those who didn't. There has been past research that's found both beneficial effects of consuming coffee, notably things like liver protection and weight loss, but then there have been other studies that have found brain damage and increased risk of things like dementia. So, again, taking this as an observational study, it's worth being aware of it. The bizarre thing here isn't just that coffee is associated with the better health outcomes. It was that it didn't really matter what kind of coffee you were having. And by that, we don't just mean whether it was fancy coffee, Starbucks coffee, whatever it is they serve at McDonald's that they call coffee, instant or granulated, even decaffeinated coffee, all had the same reduction in the risk of cardiovascular disease and similar. The strengths of the study, despite it being observational, are that it did have nearly 450,000 people with an average age of 58. The amount of data for these people was about 12.5 years worth of information, so it's not a small amount of data and it's not over a short period of time. This means that, yes, you need to be careful with extrapolating anything from it, but it does indicate that there is a pattern here worth exploring further. The problem with this is reality, and reality says that it may not even be the coffee. It could be the caffeine in it, it could be one of hundreds of other biologically active components from coffee. It's also possible that somehow the relationship between those who consume coffee and those who don't is notably different enough that it does negatively affect their life. As such, it's very hard at this point to say that the results have more meaning than, as pointed out, it's an area for future research to find out if there is something here that's worth trying to chase. Compared to observational studies, looking at actual samples of a pathology like cancer is much better. And this is where another study comes into play, where it looked at cancer, primarily from the breast, colon, pancreas, and lung, and how there seemed to be a fungus playing in a role of either the development or the progression of the cancer once it had become established. The study looked at 17,000 samples of tissue, blood, and plasma that came from cancer patients. And overall, they found that the fungus wasn't present in all of the 35 cancer types that they looked at. That's why they specifically identified 4 areas of the body that seemed to have the association. More than just an association, there seemed to be a particular range, with some of it having no fungi present and some having a significant amount present. This does come with a caveat though. They were looking for fungal DNA, and that may not be the most reliable means of identifying it, but when you have hundreds, thousands, if not tens of thousands of cells, you can't exactly process them very efficiently a lot of the time, although there are methods available. What they did estimate was that for every 1,000 to 10,000 cancer cells, there was the possibility of having at least one fungal cell. Tumours can have millions, if not billions, of cells, so this adds up very quickly. Especially if that fungus does have a relationship with either the beginning or progression of the cancer. The really weird thing that goes beyond just the fact that there's fungus there in the first place is that there seemed to be an almost symbiotic-like arrangement, with some cancers having more of particular fungi present than others. For example, some had yeast while others didn't. There was also association with bacteria within the tumour, so this means that there may be some weird interaction going on here between fungus, bacteria, and cancer. The other findings from this that can be very important, other than the strange association, is that it is possible from at least one of their studies that those with a high yeast infection, specifically the Candida variety, had much poorer surveillance by the immune system, leading to much poorer survival rates amongst those who had the cancer and Candida fungal infection. Going from cellular life from a pathological point of view to how life itself operates and a practically universal source of energy, ATP, and why this might be a practically universal means of cells generating energy and then processing that energy into a usable format. It doesn't matter if you're a tree, a human, a microbe, or some sort of weird creature that lives deep in the ocean. In all cases, you will somehow charge up a process that allows you to turn whatever it is you use as your foodstuff into ATP. Researchers have found that the ATP generation process is practically universal, but why that is the question, and evolutionary biochemists may have a sort of answer for that. The fact that just about everything on Earth uses the same 6-step process means that there must be some commonality to what's happening here. There is no other explanation as to why the same 6 different phosphorylation reactions, which are very energy intensive, need to occur. The answer, at least according to one study, is simply the way life began, and that is primordial soup. It seems that ADP, adenosine diphosphate, turns into ATP, adenosine triphosphate, in water, where other possible options simply don't work. Going from cellular operations to instead computing operations, but still on a tiny scale. The creation of a 6-qubit processor in silicon. This is a tiny quantum computer capable of making considerable calculations once scaled, but as an individual development, it's still a major stepping stone. The qubit is the equivalent of a computing bit, except in this case it's for quantum computing. The reason for the weird naming scheme is that rather than being a 1 or 0, they can exist in 2 separate states at the same time. This allows them to be able to hold on to 2 points of data rather than just 1. If you were just trying to hold on to a single byte of data, that's not very hard. It's a 1 or a 0, or in this case, one state or the other. Once you get beyond a single point of data, this is where quantum computing gets quite difficult. Getting everything to behave the way you want it to, given that it can have multiple states at the same time, you're in a much more difficult position. And that's why having 6 of them line up properly is a big step forwards. Of course, computing as a general rule is going to be the future of just about everything. Computing is practically part of every device you use on a daily basis now, and there's a good chance you may have one or more computers on you in the form of a phone, smartwatch, or similar. Your car, kitchen devices, all of these are likely to have some sort of processor in them. And so, big data is getting more and more common. Big data is generally driven by things other than your daily use items, but, for example, your phone may track your location, and Google will use this, along with data from millions of other individuals, to target ads. Your shopping behavior, if you're part of a loyalty program, may generate big data. All of this will eventually need better computing devices, and so a neural network processor that has been, let's say, inspired by biology could be the way forward. The entire system uses a water-based circuit, and this is very different to what we're used to today. General rule of thumb is water and electronics do not mix. But if you're making them in the same way biology operates, you may need water there for everything to work. The difference between this processor and more conventional processors is that it relies on charged atoms and molecules, the exact same way a battery would work to a certain extent. More conventional processors, specifically semiconductors, rely on movement of electrons. So this is where the first distinction starts showing itself. You need that aqueous or water environment in order for the ions or atoms to move freely around in it as they need to. If you had a semiconductor set up with electrons, you would only be able to get a signal from one side to the other, and it would be a static, constant signal. In fact, this is basically what every neuron in your brain, and for that matter throughout the rest of your body, does in order to be able to communicate. So it's much more similar to biological processes than it is an actual computer. For the purposes of this video, we'll leave it at the fact that they have been able to demonstrate not only that the processor can work this way, but that it can work reasonably well, but it is very early days. And so it could play a role in the near future for other things, but at this point in time, if you're after more details, see the description box below where you'll find the relevant link. Based on current and readily available technology, 3D printing of implantable computer chips may be at least a more viable option for now, at least until we get to a point in time where more advanced technology can be as easily created. And so the printable bioimplants are the future for now. This is where chips that you can make and provide for various devices, such as communication between a diabetes measuring machine and your phone, could be very useful. Other options are surgical implants. Things like being able to resume eyesight by specifically and tailor-making a particular system for an individual that can interact with the way their brain's set up. These ideas and more are covered by the Neurologica blog. This is not your conventional 3D printing. No filament deposition methods, no resin, nothing like that. Rather, it's a printing technology called aerosol jet 3D printing. which allows for very fine levels of detail. In fact, it's described as nanoscale levels of detail. This is why you can use it to develop implantable devices that interact with neurons, for instance. You wouldn't really be able to do this using things like resin or filament, not in practical terms and certainly not on scale. The blog post explains the current limitations of implantable devices, primarily that because the brain and the tissue around it move somewhat over time, you eventually get scar tissue developing because the device moves with the beating of the heart and movement of blood, leading to lost connections and scar tissue developing. This means that you need something flexible and pliable enough to go in the brain, and the standardized chip-like devices that they make now aren't practical for that. So when you combine the benefits of customizability, able to produce an object that is not two-dimensional and highly flexible, suddenly a lot of the limitations of modern implants begin to be diminished, if not entirely counteracted. That is the distant future though, and certainly not likely to occur in the next 5 to 10 years at this rate. Throwing back to old technology and the possibility that Hubble, the long-standing telescope that we've nearly lost several times now, may get a fresh lease on life. NASA and SpaceX are discussing the possibility of being able to either retrofit or repair Hubble enough to extend its lifespan at least somewhat further. At the moment, several of Hubble's parts are now getting towards the end of their life, and there are no longer any spare parts available. The entire telescope was set up with redundancies in place. This was not only because once it was deployed and that would be it, but also in case there was a breakdown on board, you could keep the device going. This means that by running out of replacement parts, you really have no more options. The proposal between SpaceX and NASA, while by no means certain yet, could mean that we continue to get one of the most useful telescopes in the outer space working, barring of course the James Webb telescope. The proposal is not without some controversy, and there are two parts to it. First, that nothing has been definitively stated yet, but rather this is a proposal from SpaceX to NASA, and NASA sees all the benefits that could be generated by doing so, notably that it keeps a very expensive and very useful piece of equipment operational far beyond when it was expected to be. The second controversy is not so easily addressed, and it has more to do with space tourism than anything else. The proposal is by two parties. SpaceX would be the functional element to this. They are the ones that have the means of executing what they want, for the most part. The other party to this is Polaris Program. They are a private company that specializes in human spaceflight. The controversy with this is that people believe that it would be largely just giving people with considerable wealth, enough so to go flying in space for shits and giggles, something to do while they're there. The final news item we have for you this week is another blog article from Neurologica, and it looks at the feasibility of hydrogen, and notably that there's been at least one significant drawback identified for it recently. Hydrogen is the proposed alternative to fossil fuels, along with renewable energy sources like solar, wind, and hydro. Hydrogen itself has practically no carbon footprint. When you burn it, you pretty much just convert it into water, a relatively inert and harmless substance for the most part. The problem is, how do you get the hydrogen in the first place? And it would appear that, at least based on the currently available evidence, that generating hydrogen on scale actually generates more CO2 than the burning of the methane used to power the process would by itself. There is also at least one other big drawback that's not related to its environmental impact, or at least not in those terms. Rather, it has to do with the efficiency of hydrogen. It would appear, based on a think tank report called the Regulatory Assistance Project, that if you were to try and heat a house with hydrogen, for example burning it in a heater or furnace, you have a lot less efficiency by comparison to something like heat pumps, which you will find in air conditioners, district heating, which is not used as much anymore, or for solar thermal. The Neurologica blog goes into details on not just the viability of hydrogen, but some of the problems with it, and more so in the context of the current alternatives, which are proven technologies, and how the different technologies stack up against each other, and you'll find a link to that in the description box below. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have